Now we will take a look at the reactions of amides. The first reaction is reduction. Amides can be reduced by the strong reducing agent, lithium aluminum hydride. And after the reduction, the product will be an amine. So amines can be prepared by reduction of amides. The second reaction is the hydrolysis. Hydrolysis of amide will provide carboxylic acids, and the reaction can take place either under acidic or under basic condition. And this is the nucleophilic acyl substitution. I won't go through the mechanism, but I suppose you will know it already. Something that's special that I want to point out here is that after hydrolysis of amides, we should have a carboxylic acid and an amine. We know carboxylic acids are acids and amines are bases. So under either acidic or basic condition, there will be another acid-base reaction. For example, as shown here, since it's under acidic condition, the products, the base will react with the acid. So the amine will react with the acid further to become protonated. As a result, hydrolysis of amide under acidic condition will give an alkyl ammonium ion. Amine will be protonated in acid. Here is an example. So we have a primary amide which will be hydrolyzed with sulfuric acid. It's going to give the corresponding carboxylic acid as well as ammonium bisulfate, the ammonium salt. While under basic condition, the acid product will be deprotonated to form carboxylate. Okay? So the carboxylic acid product will be deprotonated in the base. And the acid-base reaction after the nucleophilic acyl substitution actually drives the overall reaction to the hydrolysis product. So for amide hydrolysis, no matter if it's under acidic or basic condition, they are irreversible. I just want to remind you about ester hydrolysis. For esters under acidic condition, the reactions will be reversible, right? Fischer esterification and hydrolysis of ester, they are under equilibrium. Under basic condition, because of the formation of carboxylate, it becomes irreversible. That's for esters. For amides, no matter if it's acidic or basic condition, irreversible due to the last step, the acid-base reaction. Alright, so here is an example of a basic hydrolysis of an amide. Can you provide the product? We will get the carboxylate ion and the amine. Now I just want to go over the mechanism for basic hydrolysis very quickly. This is the nucleophilic acyl substitution. So under basic condition, hydroxide is the nucleophile. It's going to attack on the carbonyl carbon of the amide, breaking the CO double bond. Then it will form the tetrahedron intermediate. The O- here can pick up a proton from the solution to become an OH group. The NH2 group can get a proton from water to become a protonated amino group. Then the collapse of the tetrahedron intermediate, we have the base grabbing the H on the OH, carbonyl reforms, and the NH3 leaves. That gives carboxylic acid and ammonia. But since it's under basic condition, carboxylic acid will be deprotonated by the base to form the carboxylate. And it's this last step that makes the overall reaction irreversible. Well, even though hydrolysis of amides under either acidic or basic conditions are irreversible reaction, the hydrolysis of amides it's actually not easy to do. Let's see why. Under acidic condition, we know the oxygen of the carbonyl can be protonated, and we can write a resonance form for this protonated amide. And in the resonance form, the nitrogen helps to share the positive charge. And now we have a carbon-nitrogen double bond. Under basic condition, it is possible that the proton on the nitrogen could be removed by the base. And we can also write a resonance structure for this anion where the oxygen can help to share the negative charge. And in the resonance structure, again, we also have a carbon-nitrogen double bond. So the carbon-nitrogen bond actually has some double bond characteristics. So because of the strong electron donating ability of the nitrogen, the carbon-nitrogen bond is it's not easy to break. So even though hydrolysis of amides are irreversible reactions, amides are not easy to hydrolyze. And the amide linkage are stable. Later we will talk about proteins, and the proteins are all made through the amide linkage.